Alright, so this past week we went over reversing motors, and then we had you do a lab using two contactors, creating an electrical and mechanical interlock using those push buttons, and that seemed to cause a little bit of confusion. So we're going to go over just the push button part, and we're going to give y'all another try this week so that way you don't go into it more confused than when you first started. So I previously told y'all, I had previously told you guys that we were going to run the overloads after we did the push button. So we would go straight from the 24 volts through our stop button. And that's what I told y'all. And the overloads would be at the end of the circuit so that they were separate. So we would have a forward overload and a reverse overload. Just to explain a case that we're going to need that, like, for example, an escalator, you would need it to still be able to reverse if the forward overloaded. So you get a handbag stuck, a kid stuck, whatever, you're going to still want that escalator to be able to reverse even if it overloaded in forward. But for most applications, we can run the overload protection before the stop button. So what that's going to mean is if we run those 95 and 96 overload, normally closed contacts on that contactor, then if one of them trips, the whole thing trips. So you're not going to be able to have a separate forward and reverse. And we're just going to run it like that to make it a little bit easier. So how it's going to be set up is you're going to come from your 24 volts. Okay? So we're coming from our 24 volts, and we're going to go through our 96, normally closed, and then we're going to come out of our 95, normally closed. We're going to go into our 96, normally closed on our other contactor, and we're going to go out of our 95, normally closed on our other contactor, and then we're going to go through our stop button. So, how we had it set up before was these were all the way at the end, right? But now we're doing them at the beginning to make things just a little bit easier. So, we're coming from our 24 volts, going through our normally closed contacts on our contactors. So, the only one you have to jumper is you go into the 96, you jumper 95 and 96 together, and then you come back out of your other 95 through your stop. And that's just putting your overloads before your stop button. Alright, and then we come out of our stop, which is a normally closed. We know that. And we're going to go through our forward. The normally open of our forward. We also have a normally closed of our forward. Okay? Let's see. Alright, so this is where it gets confusing for people, and I can understand why. On this side of our normally open, it's going to go 13 as well. And on this side of our normally open forward, it's going to go to 14-22. Okay? So that's the first two wires. Not only do we have the 24 volts coming in here, we also have a 13 on that side of the push button. And we also have a jumper to reverses normally open. So we have 3 connections to that side of that push button. Okay? Alright. So we've got, I'll just do these all different colors so that way you can see that there's 3 connections. So we've got 13 on that side. I call that the inlet side. You can call it input, inlet, whatever you want to call it. So we've got the 24 volts going to there. Then we have 13 coming out of there. And we also have one going to the other side of the normally open reverse. Now that is just making sure that we have 24 volts. So I'll just do that in red. So we'll keep the 24 volts in red. Okay. So 24 volts is red. So we know we got 24 volts going to the input side of our forward, into the inlet side of our reverse normally open as well. And also, same thing down here. we're going to have a 13 and a 14-22. Okay? Alright. So all that is done. And now we need to worry about our normally closed forward and reverse buttons. So I'm just going to use a blue to show what we do with those. So we come out of our normally closed forward and we go into the outlet side of that normally open reverse. Okay? And then we come out of our normally closed reverse and we're going to go to A1 of your forward contactor. So you've got your A1 right here. And then you're just going to go on to 0 volts, also known as A2. Okay? And then out of your normally closed inlet side of your forward contactor, you're going to come down here and you're going to go to the reverse A1 and then on to your 0 volts A2. Now this front side of this normally closed reverse right here is going to go to the outlet side of your normally open forward. And we've already said that our normally closed goes right here. Okay, so everything is now connected. So let me just trace this out. So we got 24 volts going through our overloads, right? 95 and 96 jumper to the other contactor coming out of 95, going through our normally closed stop button. Out of our normally closed stop button, we're going to go to the input side of the forward. We're going to go to the input side of the reverse, normally open contacts. On that side, we're also going to have a 13 and a 14, 13 and a 14. 13 and 14 are associated. 13 and 14 are going to be with the normally open contacts. Okay? Alright. So then talking about our normally closed, because that seems to be the one that confuses most people, we're going to come out of our forward, normally open. We're going to go in to our reverse, normally closed. Alright, and then talking about this reverse, we're going to come out of our reverse, normally open, and go in to our forward, normally closed. So then we come out of our forward, normally closed. We go to A1 of reverse. So you're just doing the opposite. So whenever you come out of these normally closed, you go to the opposite contactor. So since we're coming out of the forward, normally closed, we're going to the reverse A1. Alright. And then we obviously know that the 0 volts is just A2. So we just jumpered them and sent them to 0 volts. And then, let's see if you can see that part over there. Okay. So you see how I've got coming out of my reverse normally closed, we're going to forward A1. So, let's just put this up here. So, A1 reverse equals forward normally closed. A1 of forward equals reverse normally closed. And I'm going to have this drew out for you a little bit better so you can see it in the cabinet. But really just focus on the push buttons this week, because if we put those overloads in the front, it makes it a little bit easier. Just focus on, you've got 13 and 14 associated with your normally open. And then you're doing the opposite with the forward and reverse normally closed. So you come out of your normally open forward, you go into your normally closed reverse. That's all you do with that one. Then you're just coming out of that one and going to your A1 of your forward. Then you come out of your normally closed reverse and go into, you come out of your normally closed forward and go into your normally open reverse. Alright, so I know that's just a mess. I know it's been confusing, but I'm going to have it drew out a little bit better on the motor control cabinet. And I know that it's still going to probably be a challenge this week, but it's better to touch it twice and kind of understand a little bit of what's going on. This is going to be probably the hardest lab you do. So really take your time and try to figure out and make it look neat. Like make your wiring be neat. Use the Panduit. Use the Panduit. And we obviously know that our contactors right there. So we've got our two contactors, 24 volts, 0 volts. We've got our 3-phase up here. But whenever you're wiring these, like if you've got your 3-phase coming, come into this Panduit and wire it like that. And then if you're coming out of the bottom, I know it's hard to wire those push buttons, but just use this Panduit until you get over here and then jump to the push buttons. It makes it look a lot easier. It's easier to see if you've made a mistake if you wire it correctly. It just makes everything a lot easier. And this is how the motor control cabinet should look anytime you get into it. It should be clean. It should be neat. Nobody else should leave their lab in the motor control cabinet. This is how the table should look. I mean, you don't have to make it look pristine, but at least picked up. All the tools are on there. There's no spare, just wire just laying around willy-nilly. Somebody rolled it up at least. It should look neat. Obviously, you know which breaker to trip. Always verify that breaker is off before you work in the motor control cabinet. I've labeled it motor cabinet, so you always need to verify that is in the off position before you get into that cabinet and start working. And the last thing is you need to take an ohm meter and you need to check those terminals up top at the disconnect and make sure they do not have AC voltage on them. So just a summary, you need to clean up your workspace. You need to wire neatly because we're going to start taking points off for not cleaning and wiring neatly and everything. You need to verify that there's no voltage on those terminals at the disconnect. And you need to make sure the breaker is off before you ever